Hi everyone. So next we want to discuss bugging, random forests, boosting. So these are more sophisticated methods for trees. So tree-based methods have a high variance, so the result is unstable. So one typical example is here. We discussed it a few days ago. So if we have the 4 observations here and 10 observations here and 3 observations here, optimal threshold is here. But if we have 2 additional observations here, the threshold comes here. So it's really unstable and it really depends on the data. So today at first we discuss bugging. So this is the randomize. The idea is to randomize the training set to make a tree and repeat the procedure and take the average. Okay, so tree is highly discrete, not continuous separation of the data. But if you just change your training set a little bit and the take average, then we can get more smooth the boundary. So to be exact, the algorithm is here. So suppose that we have n observations in the training set. Then we repeat the following procedures for b times, capital B times. So at first, so bootstrap n observations with replacement from the training set. So we randomize it somewhat. So with replacement, so that means, for example, if we have 6 observations, 1, 2, 3, 4, 5, 6, then bootstrap. So maybe the result is 5, 3, 1, 3, maybe 2, 1. Okay, so this may be bootstrapped dataset. So with replacement. Then they fit the regression tree and let the f hat maybe b, sub b of x is the fitted function. Then we repeat this many times and the average, the f hat back, is defined as the average of this dataset. So of course we have to decide several hyperparameters. For example, this b, how many trees we make. Actually, this isn't really important to determine the prediction performance. And also the maximum number of nodes for each tree. So this can be specified in the max node function in R, max nodes option. And also the minimum size of the terminal node. So yeah, so if the minimum size is small, then we can get the larger tree. But actually, because of this bootstrapping, these parameters are not as important as the hyperparameters in more naive, the basic tree methods. So just I want to illustrate the situation, the idea of bugging. So think about the some data, and suppose the data isn't really easy to be treated by tree. For example, these observations. So if the straight line, it's good, but otherwise it's not really good. Tree-based method, we have only some splits. So suppose for simplicity we can get just one split. Okay, so then we get the in the bugging that we bootstrap and we take the average. So suppose first maybe we take this observation once and maybe this observation twice, maybe this observation twice, and also maybe this observation once. Okay, then what happens? Probably the split is around here, and the average is here, and average is here. Okay, so this is the one bug. So this is this function, this red curve. Maybe this should be just dashed line. So this is just a boundary, and we have two curves. Okay, so this is the f hat 1 of x. X is this predictor, and the y is here. And how about the second one? Suppose we have some more the skewed sets, such as maybe 1, 2, 3, 4, maybe 5, 6 or something. Then, okay, so it's a little bit harder. Maybe it's not very skewed, so maybe we get this one. Okay, so then what's the best way to split? Maybe I don't really know, but suppose this is the boundary, then average is here, it's higher, and here it's lower, but it's higher than the last time, so like this. And next time maybe we get the 2 observations here, maybe 1 observation here, 2 observation here, and 1 observation here. Then what's the best split? Maybe maybe we want to get a little bit different one, maybe here. Then maybe split comes here. Then average is here, and average is here. So, okay, so this is f hat 2 of x, and this is f hat 3 of x. So if we take the average of these three, so 1/3 times b is equal to 1, 2, 3 f hat of bx, then probably that we get more smooth function. So probably that we average out these three functions. So it's not clear, but okay, so suppose this split, maybe this was 10, then this is a little higher, so 12 maybe, and this is lower, so maybe, I don't know, maybe 7 or something. So we have the 7 here, and the 10 is around here, and the 12 is around here. Then the average is smoother curve, so less than 7 maybe like this, and 7 to 10 maybe around here, 10 to 12 maybe around here, more than 12 around here or something. So this looks better than each of these. Okay. So we can expect bugging is better than the usual regression tree. Okay, so this is the basic idea of bugging. So next time that we do some more tools for bugging. Okay, see you then.